minutes instead of 10.
Thank you.
Hi, good afternoon. My name is Yong. I'm going to present one of my students' PhD topic. He's in internship, so he couldn't attend here. So this is about SLAM. Yeah, so I'm kind of mapping guy, so using the SLAM for robot. Localization. So SLAM means simultaneous localization and mapping. So localization of the robot is very important. How they do it? They measure 10 meters, maybe 5 meters, 3 meters, 1 meter, then I know where I am in this room, right? If there's nothing, I have no idea where I am. So SLAM needs something. So it's good for indoor. You don't need a GPS system. So once we know the location, I mean, you can do so many things there. So even if you create a mapping map, 3D point cloud as well. So I'm not talking about application of the SLAM, but I'm mainly tackling SLAM algorithm today for the first time in ISARC, not any other conference. So how it works, it also measures the feature extraction like image data from comparing previous map, which is laser there? No. Should be laser, right? Oops. It's okay. So previous map and pose of the robot and the sensor data get features. What's the feature? So surface and edges or some of the surface kind of element, something. It doesn't know what it is, but it detects geometry and then compare those things and then estimating the pose and then matching with the previous one and estimating and then create a new map and pose of the robot. That's the kind of repeating process. The main reason I asked the previous number one, present what kind of SLAM you use it, but most likely you probably know that most of the people using this LiDAR SLAM. So it has a LiDAR plus IMU, so measure the motion. So so we trying to challenge this guy. So we develop our own one. We find out a lot of problem on this one in construction site because when it doesn't have enough floor information, ceiling or here, even if autonomous process, it couldn't go through the door, the small door, the small hallway. So we decide, that's motivation, we decide our own algorithm. This is a real SLAM, but you can see a lot of shaking thing, but we'll talk about that later more. Oh, it's very clean, right? So that's ours. So I'll talk about more detail. So this is a novelty what he did it. I mean, I'm kind of excited to announce this kind of thing in ISARC for the first time, but we did some unique techniques here. LiDAR SLAM didn't do it. So LiDAR SLAM developed 4 years ago, by the way, IRAS conference IEEE. So we process organizing point cloud before doing it. Also, we have some feature extraction like a normal. We measure surface normal. They don't. So we have much crisp, sharper images you can see here. And the key frame is, we don't process just matching frame to frame. We try to extract those things to the frame. So we save a lot of time, memories, and then we can have more sharper images here too. So what we use is, I don't know if you heard about it, but here this SLAM challenge was the 2022 in ICRA. Actually, we organize a robotics workshop every year in ICRA. But this is 2022. We use their data set. Their data set has 3 construction sites and 2 indoor. And the nice thing about that, they provide the ground truth. So you can easily measure the accuracy, something like the errors. So, and then one of them is very challenging one. It's a curved one, and there's four steps there. One of the problem we found from the LiDAR SLAM, it has some problem not only planning information, but even the step there, it lost tracking. So altitude changes, it lost tracking. So five data set we use it. So it has our name, but I'm not going to tell our name, so algorithm name yet, but it's the ours SLAM. So LiDAR SLAM versus ours. We test 5 of the data set. First 3 is construction site. This is some basement. This is a spur one. So first 3 work fine, but the other 2 LiDAR SLAM lost tracking, so it couldn't work after 5 seconds at the beginning. So, but our algorithm work all kind of cases. Only 2 LiDAR SLAM has a better accuracy, But that I'll talk about that accuracy later. But because we know that precision is more important than accuracy, right? We know that. So let's say I usually teaching mode, but accuracy. This is the answer. Accuracy should here, very good. I should just hear 5 times. This precision is very good, accuracy is bad. But this is better, right? Information, because we know how many click, bring the answer, right? But if you have an answer to here, maybe accuracy is good, but wrong precision. So precision is a much more important thing actually than accuracy. So LeoSam versus ours, as you can see, much cleaner. I mean, you can see from here in terms of precision, smoother. I'll show you more information there. Also, we test our robot. We build our own SLAM thing on top of the robot, but so we use this one for those algorithms for so many other places for another data set testing. So this is the one actually I show you. Left is ours, LeoSam is the right, and then you can see, visually see that which one is shaking, not very aligned, and drifting. Those are the why the people are just following the robot. We're using our robot or data set, something like that. So, but this is one of the our data set using robot. It's not a key one. So you can see the very clear lines here versus kind of shaking and the blurry images. So this is a LeoSam. This is our data set, exactly side by side testing. So you can definitely see this hour straight, and then not much drifting there, very clear images versus LeoSam has some kind of blurry line here, images, and then shaking a lot. I'll talk about that more detail. Since we are measuring normal, it is very important in construction, the wall thickness, right? So we inside the wall is different from outside the wall. So because we're using normal, we can tell this is wall is different wall, inside, outside. However, LeoSam doesn't know it. It is same. They consider the same wall. As you can see from here, it's kind of it couldn't measure thickness. So because it doesn't measure normal surface normal. So ours we can measure definitely thickness here. But if you ask me accuracy, I don't know. It depends on the LiDAR, like kind of performance. What kind of LiDAR are you using? More expensive, better resolution, you can have better one. But anyway, we can clearly see that difference of this wall is different from this wall because we're using this normal versus different normal. So as you can see, much clearer path. You can see sharper image versus LeoSam. Then question, which one is ours? Which is LeoSam? Which is LeoSam? Left is LeoSam, are you sure? No. Okay, as you can see, it is ours. You can see much clear guardrail plus leg, right, from the chair versus kind of blurry images again, shaking. So that's the main reason our feature extraction and then using surface normal, that works much better than LeoSam. So conclusion is, I wish I could tell you more, but we introduced here the lightweight SLAM algorithm, which perform better than one of the top popular SLAM algorithm in robotics community. We test the algorithm multiple challenging construction site, indoor data set. LeoSam has a major issues with the smaller open door or different altitude, has some losing tracking, and then we just demonstrate higher precision, greater robustness on the majority of the data set. Our algorithm work all 5 data set, but LeoSam only work for 3. Okay. Now, what's future work? As I mentioned before, LeoSam has a better accuracy in 2 data sets. As you can see, what is that one means height in terms of altitude. Ours are kind of bigger than them. So in terms of that height information, LeoSam work better. However, as you know, X to Y is more important than Z when you navigating in the kind of indoors. So ours are very accurate in yaw. There's a little better than us in terms of rolling and pitch. because we didn't use IMU for these two at the time, but now we fix this problem, newer version. Actually, this is not future, actually, we already done with the future. So new version coming, we're gonna please publish this one as paper, one of the IEEE major robotics journal. I'll let you know, let you guys know that. So we resolve these issues. Anyway, so it's no longer future, but our approach to achieve greater localization precision. And then that is very important thing for the robot navigation for many applications. So that's it. And you can easily find Leo Sam was one of the major robotics. There's ICRA and IROX are the two major components in robotics. They present there. The most popular one, I believe. Dr. Kim using Leo Sam, and everybody using Leo Sam whenever I ask. So I'm gonna send mine for very expensive. So yeah, that's it.